My dear students, welcome to Department of Chemistry, Sri JCBM College Sringeri. I am Devadas K, Assistant Professor. So in my last video class, we have seen the Carnot cycle and efficiency of Carnot cycle. Today, we'll discuss about the analytical chemistry, unit 1, in that the chapter 1, gravimetry. So what is meant by gravimetry? The quantitative analysis by weighing is called gravimetric analysis. In this method, the constituent radical to be estimated is precipitated from the solution as a compound of known composition. For example, a barium chloride which is treated with a precipitating reagent like sulfuric acid, you will get a precipitate of barium sulfate. Later this barium sulfate, which is filtered and dried and weighed. There are three methods in gravimetric analysis. So first one is the precipitation method. Second one is volatilization method. Third one is electrogravimetric method. In the precipitation method, the substance to be estimated is selectively converted into insoluble precipitate by adding precipitating agent. In the second case, volatilization method, the volatile constituent of sample under study is separated by using heat energy. Loss in weight is a measure of amount of volatilized sample. In the third case, that is electrogravimetric method, the constituent is electrically deposited in a metallic form on previously weighed cathode. Then the general principles and different steps involved in gravimetric estimation, so that is under the precipitation method. So here the different steps involved are: the gravimetric analysis is based on the law of definite proportion. In this method, the constituent radical to be estimated is precipitated from solution as a compound of known composition by adding a suitable precipitating agent. The precipitate compound is washed well to free it from impurities. It is dried and finally weighed. From this weight, the amount of constituent radical in original sample is obtained by making simple calculation. The different steps involved in gravimetric analysis are the here you can see here the preparation of the sample, the precipitation process, digestion or Ostwald ripening, filtration, washing, drying, igniting, weighing and calculation. The first one is the precipitation. A suitable amount of sample is accurately weighed. It is dissolved in a solvent to get the required solution. So this is the preparation of the sample. Next, precipitation. It is treated with suitable precipitating reagent under proper condition. It is converted into precipitate. The process of the precipitation takes place in the following steps. So different steps involved in the process of precipitations are the supersaturation, nucleation and crystal growth. What is meant by supersaturation? With the addition of precipitating reagent, the concentration of the compound formed by the precipitation reaction increases to such an extent that the solution contains more of the dissolved substances than can be permitted by its solubility in that solution. This situation is known as supersaturation. The condition for precipitation is if the ionic product exceeds the solubility product, so that condition is known as supersaturated solution. So excess solid which separates out as a precipitate. Second, the nucleation. Nucleation is a process by which extremely small number of ions, atoms or molecules combine to form very small particles called nuclei. By the deposition of the ions, atoms or molecules on the surface of colloidal dust particles present in a solution in submicro quantities. Subsequent precipitation occurs through the congregation of ions, atoms or molecules on these nuclei. So this process is known as nucleation. So third step which is involved in the precipitation process is crystal growth. The nuclei formed grow in size by further deposition of ions, atoms or molecules from the solution and settle in the form of precipitate. Here you can see in this figure a solution of precipitating. Here the solution of precipitating reagent added to a sample solution, the precipitate is formed. For example, silver nitrate which is added to sodium chloride, so we'll get a silver chloride precipitate. So next, digestion, second step, so that is digestion. So here in the case of digestion, when a precipitate is allowed to stand in contact with its mother liquor, larger crystals grow at the expense of the smaller ones. This process is called digestion. The smaller particles tend to dissolve and reprecipitate on the surface of larger crystals. The precipitate becomes purer by the digestion. Further, the particle size becomes large so that the precipitate can be easily filtered. Next step, the filtration and washing. After digestion, the precipitate is separated from the mother liquor. The mother liquor is filtered by using a quantitative ashless filter paper. So that is called as Wattmann filter paper. So different numbers are there. So that is 40 Wattmann paper, filter paper number 40, 41, 42, etc. By decantation without disturbing the precipitate. A small amount of washed liquid is added. It is stirred with the help of a policeman and then allowed to settle. The clear liquid at the top is again filtered by decantation. The traces of precipitate sticking to the walls of the beaker is removed by policeman and washing solution. The entire precipitate is transferred to filter paper with the help of policeman and washing liquid. So you can see the setup for washing and filtering the precipitate. Here the precipitate will be wet by mother liquid that can also be removed by washing. The many precipitate cannot be washed with pure water because the precipitation occurs. So therefore, example, nitric acid and ammonium nitrate is used for washing silver chloride precipitate. So next step, drying and ignition. The precipitate after filtration is heated to a constant temperature. The heating removes the solvent and volatile impurities present in the precipitate. In some cases, the precipitate is heated to convert it into a stable state of known composition. For example, in the case of iron, so here the ferrous sulfate which is converted into ferrous sulfate which is converted into ferric sulfate. Later ammonium hydroxide is added, so that means the ferric which is precipitated as ferric hydroxide. But the suitable weighing form, when this ferric hydroxide, when it is ignited, you will get a ferric oxide. So that is the weighing form in the case of iron. This is the weighing form of the precipitate. Here The precipitate must be in suitable form for weighing. The precipitate must be pure, stable, of certain known composition. Remove water efficiently, electrolytes in washing solvent. Appropriate chemical changes during heating. For example, silver chloride. So in the case of silver chloride, the temperature should be maintained between 100 to 130 degrees Celsius to remove physically bound water. Higher temperature is necessary if water is trapped in crystals or chemically bound water, or ensure appropriate chemical changes. For example, you can see here the calcium oxalate, so which decompose to give calcium oxide, calcium oxide at 1100 degree Celsius. I will stop at this stage. We'll meet in the next video class. Till then, stay home, stay safe. Thank you.